In the beginning there was no light, no sound, no time, just an endless invisible pressure holding everything that would ever exist, every galaxy, every atom, every heartbeat, inside a single point smaller than a grain of dust. Then, without warning, reality ignited. In less than a fraction of a second, everything exploded outward in a storm of creation so violent it forged the laws of physics themselves. Space stretched faster than light could travel, and from that chaos came order, matter, energy, gravity, the ingredients of everything that would one day become stars, planets, and life. But this was only the first act of an ongoing cosmic war, one fought not with weapons but with forces so powerful they can bend space, devour light, and tear apart the fabric of existence itself. Every second, the universe is rewriting its own story. Stars are born in clouds of fire and dust, burn for billions of years, and die in violent detonations that outshine entire galaxies. Invisible fields hold atoms together, while unseen energies rip galaxies apart. Black holes twist time into knots, and somewhere beyond the reach of our telescopes, new universes might be forming in the dark. The same forces that sculpt the stars also built you. The calcium in your bones, the iron in your blood, the gold in your jewelry, they were all created in explosions that ended worlds and began new ones. You are made of stardust and chaos, bound together by invisible power. So what is the most powerful thing in existence? Is it the black holes that swallow everything in their path? The dark energy pushing galaxies apart faster every second? Or could it be something far more mysterious, the universe itself, aware of its own creation through the eyes of those who can finally understand it? Tonight, we journey into that question to witness the power that built everything, destroys everything, and somehow still finds a way to create life from the ashes of stars. Deep inside every atom in your body, inside every breath you take and every heartbeat you feel, a silent war has been raging since the beginning of time. A war so small we cannot see it, yet so powerful it holds the entire universe together. The soldiers in this war are protons, tiny spheres of positive charge packed together inside atomic nuclei. According to every law of logic, they should not exist side by side. Positive charges repel. They should explode apart instantly. If nature followed only that rule, no atom could ever hold itself together. There would be no elements, no stars, no planets, just a sea of scattered particles drifting through eternal darkness. But something extraordinary happened. Against all odds, these protons stay locked in place, bound together by a force so overwhelming that it crushes their natural repulsion. Scientists call it the strong nuclear force, and it is the mightiest interaction known to science, the ultimate glue of reality. The strong force operates on distances so tiny that they defy comprehension. It acts only within the heart of the atomic nucleus, over ranges smaller than a femtometer, a millionth of a billionth of a meter. Yet within that impossibly small space, it reigns with absolute power. To put its strength into perspective, imagine this. If gravity were a whisper, a strong force would be a thunderclap that could shatter worlds. It is 100 times stronger than the electromagnetic force, and 100 trillion times stronger than gravity. This invisible bond is what keeps the universe from falling apart, what allows matter itself to exist in stable form. Without it, everything you see would simply fly apart into dust. The strong force works through particles known as gluons, the universe's smallest and most relentless chains. Their name comes from exactly what they do. They glue other particles together. Each gluon binds particles called quarks, which are the fundamental building blocks of protons and neutrons. But this isn't an ordinary bond. The more you try to pull quarks apart, the stronger the force between them becomes. It's like trying to stretch a rubber band that grows thicker and more resistant the further it's pulled. Scientists call this strange behavior confinement. It means that you can never, under any circumstances, isolate a single quark. If you try, the energy you add to separate it simply transforms into more quarks and gluons. The chain doesn't break, it multiplies. Inside every proton, 3 quarks are trapped in an endless dance of pure energy, spinning and vibrating within their prison of gluons. They never stop moving. The gluons themselves also carry the strong force, forming an intricate web of interaction so complex that even our most advanced supercomputers struggle to simulate it. Each quark pulls on the others with unimaginable tension, and the energy trapped within those bonds accounts for nearly all the mass of ordinary matter. The protons and neutrons that make up your body are not heavy because of the quarks themselves. They are heavy because of the swirling storm of energy inside them. In a very real sense, you are not made of solid particles, but of confined energy, tiny fragments of the universe's original fire, locked in a cage of invisible power. At first glance, it might seem like this force is perfect, an unbreakable bond holding the universe in order, but the strong force has a weakness. Its power fades almost instantly beyond the edge of the atomic nucleus. It doesn't reach across long distances like gravity or magnetism. It is an intimate force existing only within the closest embrace of matter. Step just beyond its reach, and its grip vanishes completely. This delicate balance is what allows the universe to exist as we know it. If the strong force was slightly weaker, protons would never bind together, and the universe would be nothing but hydrogen gas drifting through endless night. If it were even a tiny bit stronger, protons would fuse too easily, and all matter would collapse into heavy elements in an instant. Stars could not shine gradually. They would erupt and die almost as soon as they were born. Every second of existence depends on this razor-thin balance, an invisible fine-tuning that makes the difference between a living universe and a dead one. To truly grasp its power, imagine trying to separate two protons inside a nucleus. Their positive charges repel each other with immense force, but the strong force resists, pulling them back together with the strength of cosmic superglue. It would take the energy of an atomic explosion just to pry them apart. That's why nuclear weapons and reactors release so much energy. The strong force is what you're tapping into. When the nucleus of an atom is split, even slightly, the energy that held it together erupts outward in a wave of heat and light. The power of the sun itself comes from the strong nuclear force as hydrogen atoms fuse together under crushing gravity, releasing energy that sustains all life on Earth. Every sunrise you've ever seen is a direct expression of the strong force at work, and yet for all our technological power, we barely understand it. The mathematics that describe how gluons and quarks interact, known as quantum chromodynamics, are among the most complex equations ever conceived. They reveal a universe that is anything but simple. Inside every proton lies a storm of color charges, red, green, and blue. Not colors in the visual sense, but labels for how quarks exchange gluons. The gluons themselves also carry color, constantly swapping identities in a dizzying dance that never ends. This constant motion means that the vacuum inside a proton is not empty. It's a roiling sea of virtual particles, appearing and disappearing in trillionths of a second. It's chaos contained, a storm wrapped inside stillness. Think about that. The same energy that powers stars and fuels nuclear explosions is locked inside the atoms of your body right now, quietly holding everything together. The strong force doesn't just bind matter, it defines it. Without it, there would be no chemistry, no biology, no consciousness. Every breath you take is possible, because protons don't explode apart in rebellion against their own nature. The force that holds your atoms together is the same force that lit the first stars and forged the elements in their hearts. The same power that created the universe's first light still burns, quietly, inside you. And yet even this force, this unimaginable strength, has its limits. Beyond the atomic scale, its power fades to nothing. Out there in the vastness of space, new forces take control. Gravity begins to dominate, shaping the fates of stars and galaxies. Where the strong force binds matter together, gravity pulls it together on cosmic scales, creating suns, black holes, and entire galaxies from clouds of gas and dust. But the strong force remains the unseen foundation beneath it all, the hidden structure without which none of those celestial bodies could exist. It is the universe's original architect, the invisible power that allows everything else to happen. Every time we split an atom or witness a supernova, we are watching the strong force at work. When stars explode, it's because they've exhausted their nuclear fuel. The balance between the strong force and gravity collapses, and the universe briefly remembers its raw, violent origins. Those explosions scatter the heavy elements that become planets, oceans, and people. In a way, the strong force isn't just holding the universe together, it's writing its history, shaping its future, and deciding where life can exist. It's the cosmic glue and the cosmic storyteller, all in one. But the story doesn't end inside the atom. For every force that binds, there is another that seeks to break. Beyond the realm of quarks and gluons, Beyond the delicate confines of matter, new powers rise, forces that stretch across galaxies, that twist light and space, that tear entire stars apart in moments. Forces that make even the strong nuclear bond seem fragile by comparison. And when those forces clash, the results are so violent that they can outshine the entire universe. Because in the end, the strong force may be the foundation, but it's only the beginning of the universe's true power. The question is, what happens when that foundation is tested? When the forces that hold reality together collide with the ones that want to destroy it? The answer lies beyond the atom, in the death of stars, in the darkness of black holes, and in the unseen energy that pushes galaxies apart. The strong force built the stage, but the next act in the cosmic story will show us what happens when creation meets annihilation, and the universe reveals just how far it's willing to go to keep itself alive. Somewhere in the silent black between galaxies, a star 100 times larger than our sun reaches the end of its life. For millions of years it has been burning through its nuclear fuel, holding itself together through a delicate tug of war between two forces: gravity, which wants to crush it, and the energy of fusion, which fights to push it outward. But now, that balance is gone. The fuel that kept the star alive has been exhausted, and in the last seconds of its existence, something extraordinary happens. Gravity wins. The star's core collapses under its own weight, igniting one of the most violent events the universe has ever known. In the blink of an eye, it releases more energy than our sun will emit in 10 billion years. It's called a gamma-ray burst, and it's the closest thing to a real cosmic apocalypse that nature can produce. If you could watch this happen, you wouldn't even have time to react. A massive star, its mass 2050, maybe even 100 times greater than the sun, implodes in silence. Deep in its core, matter crushes in on itself so fast that the temperature climbs to hundreds of billions of degrees. The core collapses to form a newborn black hole, an object so dense that not even light can escape its pull. But as the black hole forms, it doesn't swallow everything quietly. The collapse creates a maelstrom of chaos, a disk of superheated matter swirling around it, spinning at nearly the speed of light. The black hole's magnetic fields, twisted to impossible strength, act like cosmic cannons firing twin beams of energy from its poles. These beams punch through the collapsing star and tear into space at nearly the speed of light. For just a few seconds, those beams will outshine every star in the universe combined. If you were to look at one from across billions of light years, it would appear brighter than the full moon, even though it came from a galaxy you could never otherwise see. The power released is beyond human comprehension. Astronomers estimate that in 10 seconds, a gamma-ray burst emits as much energy as our sun will produce over its entire lifetime. 10 seconds of fury brighter than 1 trillion stars. 10 seconds that can reshape entire galaxies. In 2022, one of these events shook the scientific world. It was nicknamed the Boat, brightest of all time. Its light traveled more than 2 billion years before reaching Earth, yet it was so intense, it overloaded gamma-ray detectors across the solar system. Imagine standing on Earth and seeing a flashlight beam from another star system shine as brightly as a car headlight. That's the scale of this explosion. For a brief moment it changed our planet's upper atmosphere, a pulse of radiation from a dying star halfway across the universe. It's hard to even grasp what that means. Light that began its journey when life on Earth was microscopic reached us in our time, carrying a message from the early cosmos. Even in death, stars are powerful beyond imagination. Gamma-ray bursts are not just spectacular light shows, they are creators and destroyers in equal measure. When these massive stars die, they forge the heaviest elements in the universe: gold, platinum, uranium. Every ring on a finger, every circuit in a computer, every trace of heavy metal in your blood may have originated in a burst like this one. But these explosions are not gentle gifts. If one went off too close to Earth, say within a few thousand light years, it could strip away our atmosphere and sterilize the planet in moments. Astronomers believe that such bursts may have caused mass extinctions in Earth's distant past, invisible assassins that ended entire eras of life before we ever existed. What makes these cosmic explosions even more haunting is their precision. The jets that erupt from the dying star are unbelievably narrow, like lasers that stay perfectly focused across millions of light years. If a gamma-ray burst isn't pointed directly at you, you might never know it happened. But if it is, if that invisible beam aligns with your world, There is no defense, no warning, no survival. The light arrives, and everything it touches is rewritten. The energy inside those jets is a form of matter moving at relativistic speeds, 99.999% the speed of light. That's so fast that even time itself slows down for it. Within those streams, protons and electrons are accelerated to energies trillions of times greater than anything we can achieve on Earth. Our most advanced particle colliders are like toys compared to what nature does effortlessly in the death throes of a star. Every second, particles slam into each other inside the jet, releasing bursts of radiation so intense they bend the structure of space itself. These are the most extreme conditions the universe can naturally create, factories of destruction that also forge the very ingredients of creation. But the story of gamma-ray bursts doesn't end with one explosion. Each one leaves a permanent mark on the universe. The shockwaves they send through space ripple outward for millions of years, compressing clouds of gas, sparking the birth of new stars, and seeding galaxies with the raw materials for planets and life. Destruction and creation always intertwined. From the ashes of one star's death, countless others will one day be born. To truly understand how violent these events are, imagine the entire sun collapsing in on itself and releasing its mass as pure energy in less than 10 seconds. The resulting shockwave would vaporize anything within light years. But these dying giants are not one sun, they are dozens, sometimes hundreds of times more massive. When their cores collapse, the gravitational pressure is so immense that atomic nuclei are crushed into a sea of neutrons, and the collapsing mass forms a black hole in less than a heart. That's the moment when nature stops playing by the rules we understand. In the chaos of collapse, magnetic fields twist and stretch until they snap, releasing energy in violent bursts of radiation. These bursts travel through the star's outer layers, punching through them like bullets through glass, creating the tightly focused jets that define gamma-ray bursts. Even as the star tears itself apart, its magnetic heart remains strangely ordered, channeling its death into beams that travel across the universe. And long after the star itself has vanished, those beams continue racing through the void, carrying the memory of its final seconds to distant worlds. What makes the study of gamma-ray bursts so haunting is how ancient their light is. The most distant ones we've detected began their journey when the universe was less than 1 billion years old. Their light has been traveling ever since, crossing epochs, passing through the rise and fall of galaxies, until finally reaching our telescopes billions of years later. To witness one is to look directly into the past, to see the universe as it was when the first stars were dying and the first elements of life were being forged. And yet, for all their violence, these events are crucial to existence. Without gamma-ray bursts, the universe would be a poorer place. Literally, the heavy elements that make planets solid, that make biology possible, that allow for chemistry and electricity, all trace their origin to moments of cosmic annihilation. Every explosion that tears a star apart also scatters the seeds for future worlds. In that sense, gamma-ray bursts are not merely destructive, they are creative acts written in fire. The irony is staggering. The most catastrophic events in the cosmos are also the reason we're here to study them. Every human being, every tree, every stone, carries the fingerprints of dead stars. The same forces that obliterate galaxies are responsible for the sparkle of a ring, the strength of a planet's core, and the beating of a human heart. When you look up at the night sky, you are seeing light that began its journey through the aftermath of death. The universe creates life through destruction, weaving both together in an endless cycle that has played out for more than 13 billion years. But as immense as gamma-ray bursts are, they are not the final word in cosmic power. Beyond them lie forces even greater, phenomena that do not merely explode, but consume. For every star that dies, there is a shadow waiting to swallow its light. In the darkness at the centers of galaxies, gravity becomes so intense that it bends space itself into an abyss. There, the rules of physics are rewritten, and even time has no meaning. The death of stars leads directly to the birth of black holes, the universe's most terrifying and mysterious engines, and so the cycle continues. From the collapse of a single star comes a burst of unimaginable energy. From that burst comes the heavy matter that forms planets and life. And when enough of that matter gathers again, gravity begins its patient work once more, shaping new stars, new systems, new worlds. Every gamma-ray burst is a heartbeat in the life of the universe. Brief, bright, and impossibly powerful. It's a reminder that even in destruction, there is creation. Even in the end, there is a beginning. And somewhere out there, right now, another massive star is burning through the last of its life, seconds away from collapsing into darkness and igniting the sky in one final act of brilliance. When its light finally reaches us, billions of years from now, someone else on some distant world may look up and wonder what it means. They'll see that same impossible flash of energy, and they'll ask the same question we ask now. How can something so destructive also be the source of everything we know? The answer lies in the truth of the cosmos itself, that creation and annihilation are not opposites, but partners. One cannot exist without the other. And in that eternal exchange of fire and darkness, the universe continues its work, building new worlds from the ashes of the old, again and again without end. At the heart of nearly every galaxy, including our own, lurks something so powerful, so absolute, that it bends reality itself. It doesn't shine, it doesn't radiate warmth, it doesn't even have a surface or shape in the way we understand. Yet it rules everything around it with an invisible hand. This is the black hole, a cosmic predator that devours matter, consumes light and twists the very flow of time into spirals of oblivion. To gaze into its depths is to stare into the most extreme manifestation of gravity, the ultimate expression of power the universe can create. A black hole begins where a massive star ends. When the nuclear fuel in the core of a giant star runs out, the outward pressure that once held it up vanishes. Gravity, patient and relentless, takes over. The core collapses under its own immense weight, crushing matter down until atoms themselves are torn apart. Electrons and protons merge into neutrons, and the core shrinks to a sphere no wider than a city. If the star is heavy enough, even that neutron barrier cannot hold. Gravity overwhelms every other force, pulling the mass into a point of infinite density and zero volume, a singularity. Around it forms an invisible boundary called the event horizon. Anything that crosses it, even light, is lost forever. Beyond that point, space and time trade places. Moving forward in time means falling deeper into the black hole. This is not science fiction. We've seen their effects everywhere. At the center of our Milky Way lies a black hole called Sagittarius A, a monster 4 million times more massive than the Sun, yet small enough to fit inside the orbit of Mercury. For decades, it was invisible, betrayed only by the way stars near it moved. They orbit something they cannot see at speeds of thousands of kilometers per second, like cosmic marbles circling a drain. And then, in 2019, humanity finally caught a glimpse of the unseeable. Using a global network of radio telescopes, scientists captured the first image of a black hole's shadow in a distant galaxy called M87. It was a ring of fire, a glowing halo of superheated gas, swirling around a perfect circle of darkness. What we saw was not the black hole itself, but the light being pulled, twisted, and crushed by its gravity. It was reality distorted into art. To understand the scale of power involved, imagine this. If you compressed Earth down to the size of a marble, its gravity would barely change. But if you compressed the Sun into the size of a city, it would become a black hole. The escape velocity at its surface would exceed the speed of light. Nothing, not even photons, could break free. Space around it would curve so sharply that all paths, all trajectories, lead inward. Time itself slows near a black hole. For an outside observer, anything falling toward it appears to freeze at the event horizon, forever suspended. But for the object falling in, the plunge happens in seconds. To witness a black hole is to see two different realities unfolding at once, one frozen in time and one consumed in an instant. And these cosmic monsters are not rare. Almost every large galaxy harbors one at its core. Some are small, mere millions of solar masses. Others, called supermassive black holes, reach sizes that defy imagination. The largest known may contain the mass of 40 billion suns, packed into a region smaller than our solar system. These titans are the engines that power quasars, the brightest objects in the universe. Around them, disks of infalling gas spin so fast and heat up so violently that they outshine entire galaxies. The light from a single quasar can be seen across billions of light years, blazing through the darkness of the early universe like a cosmic lighthouse. The radiation from one of these feeding black holes can outshine 1 trillion stars, even as its source remains hidden behind a curtain of light and dust. The environment near a supermassive black hole is a realm of chaos. As matter falls inward, it forms an accretion disk, a swirling maelstrom of gas and plasma orbiting at nearly the speed of light. Friction and magnetic turbulence heat this disk to millions of degrees, causing it to radiate X-rays and gamma rays powerful enough to sterilize entire regions of space. But not all the matter makes it past the event horizon. Some of it is caught by the black hole's immense magnetic fields, twisted into narrow beams that shoot out from its poles like cosmic cannons. These relativistic jets can stretch for hundreds of thousands of light years, blasting through galaxies and beyond. The sheer precision of these jets borders on the miraculous. They maintain their focus across distances that dwarf human comprehension. A beam of particles narrower than our solar system can travel farther than the width of an entire galaxy without dispersing. Inside them, particles are accelerated to energies millions of times greater than any particle collider on Earth. If one of these jets were aimed at us, even from millions of light years away, the radiation could obliterate Earth's atmosphere in seconds. Yet these same jets shape the cosmos. They heat intergalactic gas, regulate star formation, and sculpt the evolution of galaxies. Out of the chaos of destruction, they bring order, guiding how the universe grows. For years, scientists struggled to understand how such enormous black holes could exist so early in cosmic history. The most distant quasars we've observed formed when the universe was less than 1 billion years old, yet their black holes already contained billions of solar masses. Normal stellar evolution simply doesn't happen that fast. So how did they grow so quickly? One theory suggests they began not as ordinary black holes, but as direct collapse objects, massive clouds of primordial gas that skipped the normal star phase and collapsed straight into black holes containing hundreds of thousands of solar masses. From there, they devoured everything nearby, merging and feeding until they became the behemoths that anchor galaxies today. What's most unsettling is how black holes blur the line between existence and nothingness. They have no surface, no interior structure we can observe, yet they possess measurable properties: mass, spin, and charge. They can merge, vibrate, and even evaporate over time through a process called Hawking radiation, slowly leaking away their energy particle by particle. If this theory is correct, then even the most massive black holes will one day vanish into nothingness, leaving only faint whispers of energy behind. Imagine that the mightiest engines in the cosmos eventually fading into silence, dissolving like mist after billions of years of devouring stars. But while they last, their power is absolute. If you approached a black hole, you wouldn't fall in gracefully. As you neared the event horizon, gravity's pull on your feet would become billions of times stronger than the pull on your head. You would be stretched and torn apart in a process scientists call spaghettification. Even the atoms that made you would be ripped to subatomic filaments before crossing the horizon. Time would distort. From the outside, you'd appear frozen forever, fading slowly as your light was redshifted into invisibility. To the universe, you'd simply disappear. And yet, for all their horror, black holes are not just destroyers, they are creators in disguise. The gravitational dance around them drives the formation of new stars. Their jets and radiation heat and compress galactic gas, triggering bursts of star formation in surrounding regions. They recycle matter, redistributing it through their host galaxies. Some astrophysicists even suspect that without black holes, galaxies might never have formed at all. Their presence provides the gravitational anchor that keeps the stars bound together. In a strange, poetic twist, the things that consume light are also the reason light-filled galaxies exist. But even the giants have their mysteries. Some black holes seem too massive for the galaxies they inhabit, breaking the normal correlation between galactic size and black hole mass. Others spin so fast, close to the speed of light, that their rotation drags space-time itself around them. This effect, known as frame dragging, means that near the black hole, even empty space is forced to spin. Time and direction lose their meaning. Space behaves like a whirlpool, pulling everything into its rotation. If we could safely orbit close to a supermassive black hole, the view would be beyond imagination. You would see the light from distant stars bent and mirrored around you, the entire universe warped into rings and arcs of fire. The accretion disk would blaze beneath you in colors your eyes could not comprehend. Ultraviolet X-rays and gamma rays weaving together into a spectrum of death and beauty. The closer you orbited, the slower time would move for you compared to the rest of the universe. Minutes for you could be centuries for the cosmos. You could, in theory, watch the future unfold from the edge of eternity. Perhaps that is the most haunting truth of all. Black holes are not just physical objects. They are boundaries of knowledge. They are the places where science meets its limit, where equations break down and certainty dissolves. They remind us that no matter how much we understand, the universe still keeps its deepest secrets hidden inside a darkness that even light cannot escape. And yet, those secrets call to us. Every photon bending around a black hole, every flicker from a distant quasar, every whisper of gravitational waves from merging black holes, these are messages from the edge of the possible. They tell us that reality is stranger, more violent, and more magnificent than we can imagine. But even black holes, for all their power, are not the final word. There is something even greater at work, an invisible force that does not crush or pull, but pushes. It stretches the very fabric of space-time, driving galaxies away from each other faster and faster with every passing second. It is not confined to the hearts of galaxies, but fills the entire universe. This mysterious energy is everywhere and nowhere, and it holds the fate of everything we know. Because beyond the hunger of black holes lies a power that does not devour, it unmakes. It's called dark energy, and it is the silent expansion of the cosmos itself. Out in the vastness between galaxies, far beyond the light of stars and the grip of gravity, something invisible is at work. It has no color, no mass that we can measure, no particles we can touch. Yet it dominates the universe completely. It pushes galaxies apart with increasing speed, stretches space itself, and dictates the ultimate fate of everything that exists. This mysterious phenomenon is known as dark energy, and though it makes up nearly 70% of the entire cosmos, we know almost nothing about what it truly is. It doesn't pull like gravity or attract like magnetism. It repels. It is the universe's silent accelerator, a force that grows stronger as the cosmos expands, turning empty space into the engine of its own destruction. The discovery of dark energy began, like many of science's greatest revelations, by accident. In the late 1990s, two teams of astronomers set out to measure how fast the universe's expansion was slowing down. They expected that gravity, the mutual attraction of all matter, would be gradually pulling galaxies back together, just as a thrown ball slows before it falls. To test this, they studied distant Type 1a supernovae, stellar explosions so consistently bright that they serve as cosmic mile markers. By comparing how bright they appeared to how bright they should be, astronomers could measure their distance, and by measuring their redshift, the stretching of their light, they could tell how fast the universe was expanding when that light was emitted. What they found shocked them. The universe wasn't slowing down, it was speeding up. The farther away a galaxy was, the faster it seemed to be moving from us. Space itself was accelerating. It was as though an unseen hand was pressing down on the cosmic gas pedal, driving galaxies apart with increasing force. At first, scientists thought it must be a mistake, but repeated measurements confirmed it. Something unknown was overpowering gravity on the largest scales imaginable. The name they gave it, dark energy, was less an explanation than an admission of ignorance. We could measure its effects, but not its nature. Imagine the universe as a balloon. In its early years, the balloon's expansion was governed by the energy released from the Big Bang and the gravitational attraction of the matter within it. For billions of years, that balance held steady. Expansion slowed, but never stopped. Then around 5 billion years ago, something shifted. As the universe grew larger and matter spread thinner, gravity weakened and dark energy began to dominate. The balloon didn't just keep inflating, it began to inflate faster. Every new patch of space that appeared brought with it more dark energy, which caused even more expansion. Unlike every other known force, dark energy doesn't dilute as space grows. Instead, it multiplies. The more room it has, the stronger it becomes. This has led to one of the most haunting possibilities in all of cosmology, the Big Rip. If dark energy continues to accelerate the universe's expansion unchecked, then one day it will overpower all other forces, tearing apart everything from galaxies to atoms. It would start subtly galaxy clusters drifting too far apart for their gravity to keep them bound. Then billions of years later, individual galaxies would disintegrate, their stars pulled away into the darkness. Stars themselves would lose their planets. Solar systems would unravel. Eventually, even atoms would be torn as the force stretched space faster than the strong nuclear force could hold their protons and neutrons together. Space, time, and matter would be unmade. The universe wouldn't collapse into fire, it would dissolve into nothing. Yet, paradoxically, dark energy feels weak, at least on human scales. Here on Earth, gravity reigns supreme. Even the tiniest magnet can lift a paperclip against the pull of an entire planet. But dark energy acts only across vast distances. It's not noticeable within galaxies or solar systems. It works quietly in the emptiness between them, a cosmic tide that tugs only at the grandest structures. Over billions of years, that slow pull adds up, stretching the fabric of reality itself. If you could somehow watch the universe in fast forward, you'd see it inflate like a living thing, growing faster and faster, galaxies drifting apart until even light can't bridge the gaps between them. We can measure dark energy's fingerprints everywhere, yet its true identity remains hidden. Some physicists think it might be a cosmological constant, a term first introduced by Einstein when he was trying to describe a static universe. He later called it his greatest blunder, but perhaps he was right after all. In that model, the energy of empty space itself is never zero. Even in the complete absence of matter or radiation, the vacuum hums with potential. This residual energy, sometimes called vacuum energy, would act as a repulsive force, stretching the universe at an accelerating rate. Others believe dark energy isn't constant at all, but a dynamic field that changes over time, perhaps slowly decaying or fluctuating across the cosmos. Some go further, suggesting that our understanding of gravity itself might be incomplete, that dark energy doesn't exist, but rather reveals a flaw in the way we describe space-time on cosmic scales. Whatever its nature, dark energy has rewritten the story of existence. In the far future, as it continues to accelerate the expansion, galaxies will disappear from view one by one. Their light will stretch into longer and longer wavelengths, fading into invisibility. Eventually, even the nearest galaxies will vanish beyond the cosmic horizon, leaving each one isolated in its own bubble of space. The night sky, once full of billions of stars, will go dark. To any future observers, it will seem as though they are alone in the universe. The ancient light that once connected us to the cosmos will be gone, swallowed by expansion itself. And yet, for all its ominous implications, dark energy is also a reminder of how delicate the universe's balance truly is. If its strength were even slightly different, the cosmos would look nothing like it does today. A little weaker, and gravity would have reversed the expansion long ago, pulling everything back into a fiery collapse. A big crunch, a little stronger, and galaxies might never have formed in the first place. Stars, planets, and life would have been impossible. Somehow the value of dark energy's strength sits precisely in the narrow range that allows complexity to exist. It is as if the universe were fine-tuned for the emergence of observers capable of asking these questions, a mystery that blurs the line between physics and philosophy. Scientists continue to search for clues. Observatories like the James Webb Space Telescope and surveys of distant supernovae and cosmic microwave background radiation are helping us map the expansion of the universe with increasing precision. We can see how galaxies have drifted over time, how the cosmic web of matter has stretched and thinned. Every new data point tightens the constraints on what dark energy might be, but none have yet revealed its essence. It remains the most powerful yet elusive entity we know, a ghost that rules everything, everywhere. If we could somehow grasp its secret, the implications would be staggering. Harnessing dark energy, if such a thing were possible, would mean controlling the expansion of space itself. It would be the power to reshape the cosmos, to compress or stretch reality, to command the evolution of entire universes. It's a concept that lives at the intersection of science and myth, the ability to wield the very breath of creation. But for now, dark energy is beyond our reach. It remains an unseen tide, carrying everything toward an unknown future. Galaxies that once danced together will drift so far apart that light will never cross the distance between them. Trillions of years from now, future civilizations, if any survive, will live under a lonely sky. They will see only the faint glow of their own galaxy, unaware that others ever existed. The cosmic history we observe today, the evidence of a shared universe filled with countless stars, will be gone, erased by expansion. In the end, dark energy may not destroy the universe with violence or flame. Its weapon is silence. It will not explode, but fade, pulling everything so far apart that nothing can ever meet again. It is the slow, inevitable unraveling of creation, the quiet end of everything. Yet even this destruction is part of the universe's rhythm. a balance between forces that create and forces that erase. The same cosmos that forged galaxies and life is also scripting its own disappearance, driven by an invisible energy that no mind can fully comprehend. And as terrifying as that sounds, it carries a strange beauty. The universe isn't static or eternal, it's alive in its own way, breathing through cycles of expansion and decay. Every atom, every star, every galaxy is caught in that pulse. Dark energy may one day dissolve everything we know, but without it, none of this would exist at all. The same invisible power that will end the universe also made it possible in the first place. So the question remains, what is dark energy? Is it the whisper of the quantum vacuum, the echo of the Big Bang still stretching space? Or is it something deeper, a property of existence itself, woven into the fabric of reality since the first moment of time? Until we know, we can only watch the stars drift farther apart, knowing that every night we look up, the universe has grown larger, colder, and emptier. And somewhere beyond what we can see, dark energy continues its quiet work, expanding eternity, one heartbeat of space at a time. In the darkness left behind by dying stars, a new kind of monster is born. It doesn't blaze with light or roar with energy like a supernova. Instead, it spins, furious, magnetic, and impossibly dense. It is smaller than a city, yet heavier than the sun. Its magnetic field could tear the iron from your blood from thousands of kilometers away. Its surface burns hotter than any forge. Its gravity so strong that if you dropped a pebble on it, the impact would unleash more energy than an atomic bomb. These are neutron stars, the cosmic corpses of once great suns, and among them exists an even rarer, more terrifying breed, the magnet. These are the most magnetic objects in the known universe, engines of destruction whose invisible power can twist atoms, warp space, and shake the very fabric of reality. A neutron star forms in the wake of a supernova, the explosive death of a massive star. When the star's nuclear fuel runs out, gravity crushes its core inward until protons and electrons fuse into neutrons, creating a ball of ultra-dense matter. Imagine cramming the entire mass of our sun into a sphere barely 20 kilometers across. A teaspoon of that material would weigh billions of tons more than every building on Earth combined. On that surface, gravity is so intense that a fall from 1 meter would accelerate you to thousands of kilometers per second before impact. The atoms in your body wouldn't survive even an instant. They'd be crushed into the same exotic substance that makes up the star itself. Neutron matter, a sea of subatomic particles packed tighter than the nucleus of an atom. But these objects aren't just dense, they're fast. When a massive star collapses, it conserves angular momentum, spinning faster as it shrinks, much like an ice skater pulling in their arms. A neutron star can rotate hundreds of times every second, sweeping beams of radiation across the cosmos like a celestial lighthouse. From Earth, these beams appear as perfectly timed pulses of light, earning these objects the name pulsars. Some spin so precisely that they rival the accuracy of atomic clocks. Astronomers can measure their rotation to within a billionth of a second. Every pulse is a reminder of the violence that birthed them, a heartbeat echoing from a dead star. Yet for all their power, even pulsars pale in comparison to their magnetic siblings, magnetars. While a typical neutron star's magnetic field is already 1 trillion times stronger than Earth's, a magnetar's field can be 1,000 times greater still. To put that into perspective, a magnetar's magnetic force could erase every credit card on Earth from halfway across the Moon's orbit. It's strong enough to distort atomic structure itself, stretching atoms into long needle-like shapes, aligned with the field lines. Chemistry as we know it cannot exist near a magnetar. Matter behaves differently, almost alien, bound not by electromagnetism but by sheer magnetic tyranny. No one is entirely sure how these magnetic titans form. Some theories suggest that a combination of rapid rotation and intense convection during the star's collapse creates a dynamo effect, like a cosmic generator spinning at near light speeds. The result is a magnetic field so intense that it challenges the limits of physical law. Once the magnetar is born, it burns with invisible fury. Its rotation slows as its magnetic field drains energy from its spin, converting motion into radiation. The star becomes a ticking bomb of magnetic stress, storing energy until it reaches a breaking point. When that happens, the result is one of the most violent outbursts in the known universe, a magnetar flare. In less than 1/10 of a second, A magnetar can release more energy than our sun will produce in 100,000 years. The surface cracks under the strain, sending waves of magnetic energy rippling outward. These flares can be so powerful that they affect planets across the galaxy. In December 2004, one such event from a magnetar 50,000 light-years away briefly disturbed Earth's upper atmosphere, despite the unimaginable distance. Had it been just a few light-years closer, the radiation would have sterilized our planet's surface. To visualize the sheer intensity of a magnetar flare, imagine the magnetic field lines surrounding the star as tightly wound springs. Over time, internal stresses twist these lines until they snap, reconnecting explosively and releasing a surge of high-energy gamma rays. It's the same process that causes solar flares on our sun, magnified by a factor of 1,000,000,000. In that instant, the magnetar becomes a cosmic torch, blazing with radiation that could outshine an entire galaxy. The energy propagates outward in waves, warping the vacuum of space itself. Near the star, space behaves like a crystal light. Passing through it, splits into different polarizations, a phenomenon known as vacuum birefringence, something that can only happen under the most extreme conditions. The idea that a magnetic field could alter the nature of empty space may sound like science fiction, but it's a measurable reality. In recent years, astronomers have detected polarized light from neutron stars, direct evidence of magnetic fields strong enough to reshape the vacuum itself. These observations confirm that magnetars aren't just objects of immense power, they are laboratories for the laws of physics, testing the limits of what the universe can endure. Inside their cores, pressures and densities exceed anything achievable on Earth, giving scientists a glimpse into the behavior of matter under conditions that existed only moments after the Big Bang. Despite their small size, magnetars play an enormous role in the cosmic ecosystem. Some astrophysicists believe that the most extreme gamma-ray bursts, those that release more energy in a few seconds than the sun emits in 10 billion years, are triggered by the collapse of rapidly spinning magnetars into black holes. In these moments, the magnetic field's stored energy, combined with the gravitational collapse, produces jets of pure radiation that pierce through the dying star, blasting across the universe as cosmic death beams. The birth of a black hole, the death of a magnetar, and the birth of new elements all converge in these cataclysmic events. But not all magnetars die in a blaze of radiation. Some persist quietly, their rotation gradually slowing over thousands or millions of years, until they fade from view. As they age, their magnetic fields decay, releasing bursts of X-rays and radio waves in unpredictable intervals. Each burst is a whisper from a dying giant, a reminder that even in death, a star can still speak. Astronomers have even detected strange repeating radio signals, fast radio bursts, or FRBs, that might be linked to magnetars. These signals last only milliseconds, but release as much energy as the sun emits in a day. If magnetars are indeed behind them, they may be the most powerful radio transmitters in existence, broadcasting across the cosmos in bursts of pure magnetic violence. To understand the magnetar is to understand contradiction. It is both dead and alive, silent and screaming, stable and explosive. It doesn't shine like a normal star, but its invisible energy fills entire regions of space. It doesn't move, yet its magnetic field extends for thousands of kilometers, influencing everything within reach. It is a corpse that still breathes destruction, a relic of a star that once illuminated the night, now transformed into something that defies comprehension. And yet, within all that chaos, there is order, a kind of elegance that mirrors the rest of the cosmos. The same magnetic fields that destroy also shape. They channel energy, direct particles, and sculpt the nebulae that surround dying stars. They turn chaos into geometry, transforming random explosions into spirals and arcs of light. In that way, even a magnetar's fury has purpose. It's part of a larger balance, a universal dance between creation and annihilation, between the forces that build and the forces that break. When you gaze at the stars on a clear night, you're looking at light that has traveled across time and death itself. Some of it may have passed through the remains of supernovae, through clouds charged by the ghosts of magnetars long gone. The calm beauty of the night sky hides a truth far more violent, that behind every point of light lies a history written in fire and gravity, magnetism and decay. And somewhere out there in the dark, another star has just died, collapsing under its own weight, spinning faster, glowing hotter, becoming denser than imagination allows. In a few thousand years, it might unleash a magnetic storm that could be seen across the galaxy, or it might remain silent, its immense power locked away, waiting for a moment of instability to set it free. Either way, it will endure as a monument to the universe's ability to create power beyond reason, a reminder that even in death, the cosmos finds ways to outdo itself. But the story doesn't end with magnetars. Because sometimes the dead do not rest alone. Sometimes two of these stellar remnants, neutron stars, magnetars, or some combination of both, find themselves trapped in each other's gravitational embrace. For millions of years they orbit, spiraling ever closer, their magnetic fields and gravitational waves colliding in a cosmic dance that ends in the most violent event the nearby universe can produce. When they finally meet, the universe itself trembles. The collision doesn't just destroy, it creates. Gold, platinum, and elements rarer than dreams are born in the fire of their union. The death of stars becomes the birth of worlds, and in that moment, the universe reminds us once again, even destruction can be beautiful. Two dead stars drift through the void, circling each other in a silent dance that has lasted for millions of years. They are neutron stars, remnants of suns that once blazed with the power of creation, now compressed into spheres of pure density. Each one is barely 20 kilometers wide, yet each contains more mass than our sun. Their surfaces are harder than diamond, their gravity strong enough to warp time itself. They orbit so closely that tidal forces stretch and squeeze their crusts, heating them until they glow with invisible fire. Around them, space ripples. With every turn they lose a little energy, sending out faint tremors that spread across the universe as gravitational waves, distortions in the very fabric of reality. Over time, those ripples drain their orbital energy. The stars spiral inward faster and faster, locked in a death spiral that no power in the cosmos can stop. For eons, they orbit in near-perfect balance, drawing ever closer. Each rotation steals time from their future, their orbit decaying as they lose momentum to the waves of gravity echoing across the universe. Then, one day, they reach the point of no return. Their separation shrinks to just a few dozen kilometers. The force of gravity between them grows beyond comprehension. In their final moments, they whirl around each other hundreds of times per second, moving at a significant fraction of the speed of light. The space between them boils with magnetism and radiation. It is as though the entire universe is holding its breath. Then comes the collision. When two neutron stars finally meet, the impact is unlike anything else in existence. In a fraction of a second, the energy released rivals the combined output of all the stars in our galaxy. The collision sends out a blinding burst of gamma rays, one of the most powerful explosions known to science, followed by a longer-lived, glowing aftershock called a kilonova. For a few hours, that point in space shines brighter than all the stars in the Milky Way combined. And out of that devastation, something miraculous is born. Gold, platinum, uranium, the heaviest and rarest elements in the universe. Every ring on a human finger, every bar of gold, every trace of precious metal in the crust of Earth, was forged in moments like these. The universe doesn't create gold in the quiet hearts of stars, it makes it in the most violent deaths imaginable. When those two stellar corpses smash together, atomic nuclei are torn apart and rebuilt through a process called rapid neutron capture, or the R process. In the chaos of the collision, atoms absorb neutrons faster than they can decay, building up to heavier and heavier elements. It's an act of cosmic alchemy, turning the ashes of dead stars into the matter that will one day become planets, jewelry, and life. If you could stand at a safe distance and witness such a collision, you wouldn't see just light, you'd see reality itself distort. Gravitational waves ripple outward like the surface of a pond struck by a stone. Except this pond is space-time itself. Those waves stretch and compress everything they touch, changing distances by less than a fraction of the width of a proton. Yet we can detect them. Instruments like LIGO and Virgo on Earth have recorded these cosmic vibrations, confirming Einstein's century-old prediction that gravity isn't just a force, it's the bending of space and time. When the first neutron-star merger was detected in 2017, it was a moment that changed astronomy forever. For the first time, humanity not only saw the universe through light, but heard it through gravity. That first detection, known as GW 1708170817, originated 30 million light-years away. Two neutron stars collided, producing a kilonova that briefly lit up an entire galaxy. In that explosion, astronomers identified the spectral fingerprints of heavy elements, proof that the gold and platinum on Earth were born in such cosmic events. It was a moment of awe, the universe revealing how it creates the very materials we treasure most. Even now, long after the light from that explosion faded, its gravitational echo continues to move outward, carrying the memory of that cataclysm across the cosmos. To understand the violence of that collision, consider what a neutron star truly is. A single teaspoon of its matter weighs billions of tons. The surface gravity is so immense that if you dropped a marble from a height of 1 meter, it would strike the surface with the energy of several nuclear bombs. When two such objects collide, they compress and shatter each other's crusts, unleashing energy that dwarfs any human concept of destruction. The impact creates shock waves that propagate through the dense matter, heating it to billions of degrees. The heat and pressure are so extreme that normal physics begins to fail. In those brief moments, quarks and gluons, the fundamental building blocks of matter, roam freely, creating a substance known as quark-gluon plasma, the same state that existed in the universe microseconds after the Big Bang. The collision doesn't just produce energy, it creates new forms of matter and even new objects. Sometimes the merged neutron stars collapse immediately into a black hole, swallowing much of the debris in an instant. Other times they form a hypermassive neutron star that spins rapidly, generating magnetic fields trillions of times stronger than Earth's before eventually collapsing under its own weight. Whatever remains becomes a seed for future creation, an explosion that enriches space with elements essential for new stars, new planets, and possibly new life. The light from these events tells a story written across billions of years. When we detect a kilonova, we're seeing something that happened long before humans ever walked the Earth. The photons reaching our telescopes have been traveling through space since the universe was young, carrying information about the earliest generations of stars. They remind us that time in the cosmos is vast and unforgiving, yet deeply connected. The gold in your jewelry may have been born in an event like this 10 billion years ago, long before the sun existed. Every heavy element on Earth is the fossilized memory of a collision between two dead suns. Yet for all its violence, the merging of neutron stars is also one of the most precise events in nature. Their orbits decay predictably. Their gravitational wave signals can be modeled down to microseconds. Long before the final collision, the universe itself hums with their rhythm, like a distant heartbeat, echoing through time. The gravitational waves they emit carry not only energy, but information about the masses of the stars, their spins, and even the structure of the dense matter within them. Each detection is a cosmic message, written in a language of gravity, waiting for us to translate. And what these messages tell us is humbling. The universe is not static or peaceful. It is an ongoing story of collapse and rebirth. Death creates the materials for life. Destruction brings forth beauty. The gold in a wedding ring or the uranium in a reactor core are not random accidents. They are relics of explosions so fierce they momentarily reshaped the laws of physics. The energy released in a single neutron star merger exceeds the output of all the stars in the Milky Way combined. Yet from that chaos comes the order we know as matter. If you could zoom out far enough, you would see that these collisions are part of a grander cosmic cycle. Massive stars die and collapse into neutron stars. Those neutron stars drift and pair up. Their slow spiral inward releases gravitational energy that ripples across the universe, carrying news of their fate to worlds that may not even exist yet. When they finally collide, they forge the elements that will one day make planets, oceans, and living things. Then the process begins again, as gravity gathers matter into new stars, and the universe continues its endless rhythm of creation and destruction. Perhaps the most haunting thought of all is that these events are still happening, even now. Somewhere out there, two neutron stars are orbiting each other, drawing ever closer with each passing second. Maybe in a million years, or maybe right now, they will collide, unleashing a burst of radiation that will travel through space for billions of years before finally reaching some distant observer. Maybe one day, another civilization will look up at their sky and see the light of that explosion, and from it, they'll learn the same truth we have, that life, matter, and even consciousness are all born from the universe's most violent moments. In the end, the collision of neutron stars is a paradox written in light and gravity. It is an act of annihilation that creates the building blocks of everything we value. It is death that makes life possible. It is the sound of the cosmos breathing, the pulse of existence itself. The universe does not create gently, it creates through fire, pressure, and collapse. And from that violence emerges everything, Stars, worlds, life, and the capacity to understand where it all came from. Somewhere, even now, a pair of neutron stars completes another orbit. The rhythm of their dance echoes faintly through space-time, a whisper of gravity reaching across billions of light years. One day soon, they will meet, and the universe will blaze anew. And in that instant, brief, brilliant, and eternal, the cosmos will once again forge gold from death, proving that even in the darkest corners of creation, beauty is inevitable. Far beyond the reach of any telescope, beyond the clusters of galaxies and the filaments of dark matter that weave the cosmic web together, the universe itself stretches toward an unknowable horizon. What we see when we look up at the night sky is only a fraction of what exists. An infinitesimal window into a structure so immense that our entire galaxy with its hundreds of billions of stars is nothing more than a grain of dust suspended in a vast and endless ocean. Yet, despite our insignificance, we have begun to uncover the greatest secret of all. The universe is not infinite. It has an edge, not a physical wall, but a limit in time, a boundary written in light. And that boundary tells us a story not of eternity, but of an eventual end. To understand this, we must first look at the cosmic web, the grand architecture of everything that exists. Galaxies are not scattered randomly through space. They form vast interconnected filaments of matter stretching for billions of light years. Between these glowing strands lie immense voids, regions of almost perfect emptiness, where a single galaxy may drift alone through nothingness. This structure was born in the first few 100 million years after the Big Bang, as gravity began pulling together tiny fluctuations in density left behind by the universe's birth. Over billions of years, those ripples grew into galaxies, clusters and superclusters, the visible scaffolding of existence. Every point of light in the sky is part of this vast lattice. Yet what's most haunting is that the structure is alive. It's evolving, shifting, and stretching as the universe expands. The filaments grow thinner as galaxies move apart, and the voids between them widen into cosmic deserts. What began as a tightly woven web of light is slowly unraveling under the influence of dark energy, the invisible force driving the expansion of space. As the billions of years pass, galaxies will drift so far apart that they'll no longer be connected by gravity. One by one, the cosmic bridges will collapse, and each galaxy will become its own isolated island in the dark. This future is not a theory, it's a certainty written in the mathematics of general relativity. We can already see it happening. The most distant galaxies are receding from us faster than the speed of light, carried away by the stretching of space itself. Their light, once visible to our telescopes, is fading into the infrared, redshifted beyond detection. In time, they will vanish completely, leaving behind a universe that appears smaller and emptier to those still inside it. The cosmic horizon, the limit beyond which light can no longer reach us, shrinks with every passing epoch. What was once an infinite vista is becoming a cage of darkness. But the expansion is only part of the story. Within that expanding web, entire galaxies are undergoing their own transformations. Stars are not eternal. They are born, they burn, and they die. The young, blue stars that light up spiral galaxies like the Milky Way will exhaust their fuel, leaving behind only dim embers, white dwarfs, neutron stars, and black holes. Over trillions of years, even those remnants will fade. The era of starlight will end. Astronomers call this future the degenerate era, a time when the cosmos will be ruled not by light, but by decay. Imagine a universe where the night sky has no stars, the galaxies are invisible, the nebulae long dissipated, planets have frozen, their orbits decayed. The only remaining light comes from the occasional flash of matter falling into a black hole, or the faint glow of a dying white dwarf cooling toward absolute zero. Even time itself will seem to slow, as the processes that once drove change, fusion, radiation, motion, come to a near standstill. The cosmos will grow silent, its once mighty energy spent. Yet even then, the universe will not be still. Black holes, those eternal engines of gravity, will continue to dominate. They will consume the last remnants of matter, stray asteroids, drifting stars, and even each other, merging into fewer and fewer colossal entities. For billions upon billions of years, these dark giants will rule a universe without light. But even they are not immortal. Through a process known as Hawking radiation, black holes slowly evaporate, losing mass over inconceivably long timescales. A small black hole might evaporate in a fraction of eternity, but a supermassive one, billions of solar masses in size, could take 10 years to disappear. That number is so vast it's beyond imagination, a span of time so long that even the concept of time loses meaning. When the last black hole finally fades, it will release a final burst of radiation, a whisper of light in an otherwise eternal night. That brief flicker will mark the end of structure, the moment when the universe becomes truly uniform. After that, nothing larger than a subatomic particle will remain. Space will continue to expand, stretching every remaining photon into wavelengths so long that they are effectively frozen. This is the dark era, the final age of the universe, when entropy has claimed its victory and all organized energy has dissipated. To some, this ending, the heat death of the universe, is unbearably bleak. It's a picture of existence without renewal, a slow fade into stillness where nothing ever happens again. But there are other possibilities whispered in the equations of cosmology and the mysteries of quantum physics. Some theories suggest that the universe could one day reverse its expansion, collapsing back into a single point in a fiery big crunch. Others propose that the acceleration might continue indefinitely until the universe tears itself apart in a big rip, with dark energy shredding atoms, space, and even time itself. And then there's a more radical idea that the death of one universe might be the birth of another. In the quantum foam of existence, fluctuations can create new pockets of space-time bubbles that inflate into entirely new universes with their own laws of physics, their own constants, their own potential for life. Our own cosmos may have begun as such a bubble, the child of a previous universe that collapsed or decayed. If that's true, then the end is not an ending at all, but a transition. Reality might be an eternal chain of creation and destruction, with each universe giving rise to the next in an infinite cosmic cycle. It's strange to think that in the grand scale of this story, everything we know, all of human history, every star ever seen, every thought ever conceived, exists in only the first fleeting moments of the universe's life. We are living in its morning, a brief flash of brightness before the long twilight to come. The stars that guide our nights are temporary lights, destined to fade. The galaxies that paint our telescopes will drift beyond sight. Even the atoms in our bodies, forged in the fires of dying stars, will one day decay into particles that drift through endless darkness. And yet, there's a kind of beauty in that impermanence. The fact that everything changes, that everything ends, gives meaning to the moments we experience. The stars burn out because they burn bright. The universe expands because it's alive with energy. Every breath, every heartbeat, every flicker of consciousness is a miracle of timing, a consequence of living in an age when the cosmos is still young and full of light. We exist during a rare window in cosmic history, a time when stars still shine, galaxies still collide, and life can still ask questions about its origin. If another civilization exists in the distant future, perhaps they will look at their dark sky and wonder if there was ever more. They may find ancient traces of us, faint electromagnetic whispers from long extinct civilizations, fossilized photons from a time when the universe still blazed with light. To them, we would be myths from a forgotten dawn, proof that once the cosmos was warm and alive. And maybe that's the greatest legacy we can hope for, not immortality, but memory. The knowledge that for a brief shining moment, the universe looked at itself and understood. That consciousness born from the ashes of stars rose up to ask why there is something rather than nothing. Even if everything ends, the fact that it was is enough. Because in the end, the universe doesn't need to last forever for it to be meaningful. Its story is written in cycles of fire and darkness, creation and decay, expansion and silence. We are part of that story, its observers, its participants, its fleeting voice. And though the stars will one day fade, the light they cast has already traveled too far to ever truly vanish. Somewhere, across the infinite expanse, their glow will continue to move forward, a message written in photons. We were here, and that, perhaps, is the truest power in the cosmos. Not gravity, not magnetism, not even dark energy, but the ability of matter to become aware of itself, to witness the grandeur and the fragility of existence. The universe may end in darkness, but its story will always be illuminated by that one simple truth, that from chaos came consciousness, and from silence, understanding. The universe is a storyteller, and its language is time, Every star, every atom, every collision and collapse. It all speaks in the quiet rhythm of eternity, but there's one part of the story that feels different, something that seems to break the rules of the cosmos itself. Amid the vast indifference of space, in a corner of an ordinary galaxy, on the surface of a small blue planet, the universe became aware of its own existence. Life appeared, delicate and improbable, and through life, the cosmos gained eyes to see, ears to hear, and minds to wonder. Section by section, we've watched the universe build itself from nothing, forces binding, stars dying, galaxies spinning, and now, in the most unlikely of turns, all that chaos has created consciousness. But how and why? If the strong nuclear force is what holds matter together, and gravity what shapes the stars, then life is what gives it all meaning. Yet life didn't arrive as some sudden miracle. It was the product of the same relentless physics that forged every atom in existence. The carbon, nitrogen, and oxygen in our DNA were born in the hearts of dying stars. The iron in our blood was forged in the shock waves of supernovae. The gold on our fingers was created in the collision of neutron stars. The very atoms that allow you to think, breathe, and dream are billions of years old. You are quite literally a walking archive of the universe's most powerful events. In the beginning, Earth was chaos, a molten sphere hammered by asteroids and scorched by radiation. Yet somewhere in that hostile inferno, chemistry began to flirt with biology. Simple molecules, amino acids, sugars, lipids, started to assemble, combining in ways that grew increasingly complex. Lightning sparked, volcanoes raged, and deep in the oceans, where heat and minerals bubbled from the planet's crust, something astonishing happened. Molecules began to copy themselves. From that single act of replication, everything changed. For the first time, matter wasn't just reacting, it was remembering. That was the moment the universe started keeping score. What had once been chaos began to organize. Molecules that survived long enough to make copies became the architects of life's endless experiment. They evolved, competed, and adapted. Over billions of years, those tiny replicators gave rise to cells, then organisms, then ecosystems. Each stage of evolution was a new verse in the universe's story of survival, driven by the same forces that governed stars and galaxies: energy, entropy, and time. What makes life extraordinary isn't just that it exists, but that it persists against impossible odds. The universe tends toward disorder, yet life fights to create order. It builds, replicates, and evolves in defiance of entropy, forming structures of staggering complexity from DNA spirals to neural networks to consciousness itself. Every living thing is a rebellion against decay, a brief reversal of the cosmic drift toward chaos. For a few fleeting moments, life carves islands of meaning out of an ocean of indifference. And then came awareness. Somewhere in that long evolutionary journey, a creature appeared that could not only survive, but reflect. Humans are the universe's great accident, a species whose brains became powerful enough to ask questions the stars themselves cannot answer. We can look into the night sky and see our origins written in light. We can decode the patterns of the cosmos and understand how it came to be. We can feel awe, fear, love, and purpose, all emotions that have no place in physics, yet somehow arise from it. It's easy to think of life as something separate from the cosmos, but it isn't. Life is the cosmos, made self-aware. Every neuron that fires in your brain, every heartbeat that keeps you alive, is an echo of nuclear reactions that happened billions of years ago. The energy coursing through your body is ancient starlight, captured by the chemistry of photosynthesis, passed through generations of life, and now burning quietly within you. You are a continuation of everything that has ever existed, a ripple in the long wave of creation that began with the Big Bang. When you step back and see it that way, consciousness feels like the universe's greatest trick. It took 13.8 billion years for hydrogen atoms to learn how to think. It took collapsing stars, exploding supernovae, colliding neutron stars, and expanding galaxies to create the conditions for a mind to form. And now, those minds can look back and understand how it all happened. We are not observers, we are the story made aware of itself. Yet, for all its beauty, life is fragile. The same forces that gave birth to it can erase it without warning. A single asteroid could reset the planet in seconds, A nearby gamma-ray burst could strip away the atmosphere. The expansion of the sun will one day boil the oceans dry, and beyond that, dark energy will scatter the stars until no new life can form. From a cosmic perspective, consciousness may be as temporary as a spark from flint, a brief flash in the cold eternity of space. But perhaps that's what makes it precious. Rarity gives meaning, fragility gives urgency. The fact that life exists at all, even briefly, is a miracle of improbability so staggering that it borders on the sacred. Against the infinite cold, we found warmth. Against the endless silence, we learned to speak. And against the weight of inevitability, we found ways to love, to create, and to imagine. When astronomers look out into the cosmos, they search for signs that we are not alone. Worlds orbiting distant stars, strange signals whispering across the dark. Perhaps somewhere far away, another species is looking back, wondering the same things we do. Maybe their atoms too were forged in ancient fires, their thoughts shaped by the same physical laws. If life arose once, it could arise again, and if consciousness could evolve here, it could evolve anywhere. The universe may be full of minds trying to understand the same mystery, why something exists at all. Still, the question remains, if life is the universe becoming aware, what happens when life is gone? Does awareness simply vanish, leaving only silence? Or does the universe, in some profound way, remember? Every atom that once made a thought still exists, scattered through space. Every photon that ever left your eyes continues outward forever, carrying the faint imprint of your existence. In that sense, nothing is ever truly lost. The universe keeps every story, it just rewrites them in new forms. Perhaps consciousness itself is another kind of cosmic cycle. Maybe every universe gives rise to awareness, and awareness gives rise to new universes. Maybe reality needs observers to exist at all, as some interpretations of quantum mechanics suggest. If so, then life isn't an accident, it's a requirement. The cosmos creates minds so that it can know itself, even if only for a heartbeat of cosmic time. This perspective changes everything. The universe is not dead matter expanding in silence. It's a living narrative, a self-referencing loop. Stars burn so that atoms can think. Galaxies collide so that new worlds can form. Black holes and dark energy, creation and destruction, they all play their part in an unfathomably vast design. Not a design by intent, but by inevitability. Out of chaos, complexity must eventually arise, and out of complexity, awareness must follow. Maybe that's the true meaning of existence. Not permanence, not control, but understanding. To be alive is to take part in the universe's act of self-discovery. We are fragments of the infinite experiencing itself from within. When you look at the stars, you are looking at your own origin. When you feel awe, you are feeling the universe remembering what it is. And so the story continues. Stars die, galaxies fade, consciousness flickers and returns. Across infinite scales and endless time, matter and energy keep rearranging themselves, searching for new ways to become aware. The universe has already shown us its power, the strong force that holds atoms together, the gravity that binds galaxies, the dark energy that tears them apart. But perhaps the greatest power of all is this, the ability to know. Because when all the stars have burned out and every atom has dissolved into the background of eternity, the light of understanding will remain. It doesn't need to last forever to matter, it only needs to happen once, to prove that the universe in all its vast emptiness was capable of producing something that could look at itself and say, I see you. That is the final symmetry. The universe began without awareness and will end without it, but in between it learned to dream. And maybe, just maybe, that was the point all along. There's a moment every night, when the noise of the world fades and the sky opens up like a black ocean, that we remember how small we really are. The stars above us aren't just distant lights, they're ancient messengers, still travelling from their origins billions of years ago. Every one of them carries a story older than time as we understand it. They were burning long before humanity existed, and they will still burn long after we're gone. And yet against that impossible scale, we still feel something when we look up, an almost electric sense that we are part of it all. Section by section, the universe has revealed its power to us. The nuclear force that binds atoms, the explosions that birth elements, the black holes that consume light, the invisible energy stretching space itself. But here in the ninth and perhaps most haunting part of the story, we face the question that has lingered since the beginning. What does it all mean? The more we learn about the universe, the clearer one truth becomes. It doesn't need us. The cosmos would expand, stars would burn, and galaxies would collide whether or not life ever appeared to witness it. Time existed before we could measure it. Space stretched before we could name it, and yet somehow, despite that indifference, we are here. Tiny collections of stardust that can ask questions the stars themselves cannot. Against all odds, life and consciousness emerged, and in their emergence meaning was born, not from the universe itself, but from the act of understanding it. It's tempting to think that the universe has a purpose, a grand design guiding everything towards some ultimate destiny. But perhaps its beauty lies precisely in the absence of such a plan. Everything that exists, every particle, every galaxy, every living thing, is the result of chance, of natural laws unfolding over time, without intention. There was no script written for this cosmos, no architect drafting blueprints of existence, yet out of that randomness came pattern, symmetry, and life capable of awe. The absence of purpose doesn't make the universe meaningless, it makes it miraculous. When we think of power, we tend to imagine control, the ability to shape, to decide, to dominate. But the universe's power isn't about control, it's about persistence. From the instant of the Big Bang, everything has been in motion, following the fundamental laws of physics, with relentless precision. The strong nuclear force holds the smallest pieces of matter together. Gravity pulls the largest structures into being. Magnetism and radiation sculpt the cosmos in invisible patterns. And through it all, energy flows endlessly, never created or destroyed, only transformed. Stars live, die, and recycle their ashes into new stars and planets. Life rises, falls, and rises again too is recycled, reborn every time a conscious mind looks up and wonders why. Maybe the real power of the universe isn't in its forces at all, but in its cycles. Every death leads to a rebirth. Every collapse becomes the seed for new creation. When stars explode, they scatter the elements for future worlds. When galaxies collide, they spark new generations of stars. Even black holes, those cosmic monsters of destruction, may give rise to new universes through quantum fluctuations. Everything that ends also begins. The universe has never truly stopped since it began. It has only changed form, shifting endlessly between chaos and order, light and dark, creation and silence. From a human perspective, it's easy to feel overwhelmed by this endless cycle, to think of ourselves as insignificant specks in a machine far too vast to comprehend. But insignificance is a matter of perspective. The atoms in your body have traveled through the cores of stars across eons of cosmic history, only to end up here forming a mind capable of reflection. You are not outside the universe, observing it. You are the universe observing its every thought, every heartbeat, every word spoken into the quiet night is a continuation of the same cosmic rhythm that began billions of years ago. It's strange to realize that, for all our scientific progress, the more we uncover, the more mystery we find. We've mapped the cosmic microwave background, measured the expansion of space, and glimpsed the event horizons of black holes. Yet the most fundamental questions remain unanswered. What exactly is dark energy? Why do the laws of physics take the form they do? What came before the Big Bang, or does before even mean anything? The deeper we dig, the more we find that knowledge doesn't reduce mystery, it expands it. Understanding doesn't make the universe smaller, it makes it infinitely more profound. And maybe that's the point. Maybe meaning isn't something that pre-exists in the cosmos, waiting to be discovered. It's something we create as we go. The universe is indifferent to our existence, but that doesn't make our experience of it any less real or less important. We assign purpose, we find beauty. We turn chaos into art, energy into expression, equations into poetry. The cosmos gives us raw material. We give it significance. That exchange, the interplay between the infinite and the intimate, is where true wonder lives. Think of how far we've come as a species. Barely a blink ago in cosmic time, we were primates staring at firelight, afraid of the dark. Now we're decoding the radiation left over from the birth of time itself. We've sent machines beyond our solar system, listening for whispers of the unknown. We've learned to read the stars like history books, To understand that the light we see tonight began its journey long before Earth even formed. The universe may not have given us meaning, but it gave us curiosity, and that might be the most powerful force of all. Curiosity is what turns survival into civilization, and existence into experience. It's what drove us to map the skies, split the atom, and reach for other worlds. In every generation, humans have looked at the cosmos not just with wonder, but with a need to understand. That need is written into our DNA, passed down from ancestors who looked up at the same stars and asked the same questions. The answers they imagined became myths, stories, religions, and eventually, all of it, every belief, every discovery, comes from the same place, the human hunger to find meaning in the infinite. But even as we learn more, we must face an unsettling truth. Everything we build, everything we love, will eventually vanish. The earth will fall silent, the sun will die, the stars themselves will burn out, and the universe will grow dark. If we measure value by permanence, then nothing has meaning. Yet meaning doesn't need to last forever to matter. The beauty of a song lies in its ending. The brilliance of a star lies in its fleeting light. The significance of a human life lies not in its duration, but in its awareness, the brief astonishing fact that we were here to witness the universe at all. Maybe, in the end, the question of meaning is the wrong one to ask. Maybe the better question is experience. The universe doesn't need to mean anything, it simply is, and in that isness we find our place. We are the witnesses, the participants, the storytellers of existence. The cosmos acts, and we interpret. It creates, and we remember. That partnership between matter and mind is the truest connection there is. When the last star finally fades and the universe slips into silence, the echoes of everything that ever lived will still exist in some form. The photons that once left your eyes, the atoms that once formed your thoughts, they'll keep moving, reshaping, recombining. The energy that once made you will never vanish. It will simply transform, as all things must. In a way, immortality was always built into the fabric of existence. We are temporary arrangements of eternal materials, borrowing structure from time, and that's what gives the universe its quiet grace. It doesn't promise us eternity. It doesn't offer safety, or fairness, or comfort. What it offers instead is participation, the chance to exist, to perceive, to love, to lose, to create. It gives us a stage without a script, a story without an ending, and the freedom to make it our own. So perhaps the greatest power in the cosmos isn't in the explosions of stars or the collapse of black holes. It's in awareness, in the simple fact that out of all this vastness, something can look around and say, "This is beautiful." The universe may not speak, but through us it sings. Through our eyes it sees. Through our words it remembers itself. And maybe that's enough. Maybe that's all the meaning there ever needed to be. Because in the end, everything from the first atom to the last flicker of light is part of the same story. A universe that began in silence and learned through us how to wonder. There's a strange quiet that comes after the end of everything. A silence that isn't absence, but completion. The stars fade, the galaxies stretch beyond view, and what remains is not nothingness, but the echo of everything that has ever been. The universe does not end with a crash or a scream. It ends with a sigh, a long exhale of time itself. But even in that added silence, the story isn't over, because stories never truly end. They transform just like matter, just like energy, just like us. Section by section we followed the cosmos from its fiery birth to its inevitable fading, from the violence of creation to the whisper of awareness. And now, standing at the edge of all that is, one final truth begins to emerge. A truth not about stars or space, but about meaning, memory, and the possibility of beginning again. To understand the end, we must first accept the rhythm that defines the universe. Creation, transformation, dissolution. Nothing has ever been truly lost, not since the first explosion of light tore through the darkness. The hydrogen that filled the early cosmos gave birth to stars. Those stars created the elements that made worlds. Those worlds gave rise to life, and life gave rise to consciousness. Every ending in that chain was also a beginning in disguise. And so if the universe is to end, then perhaps even that is just another transformation, a passage into something new, something beyond what we can comprehend. As the last galaxies drift into the black, as the final stars exhaust their light, the universe enters what physicists call the dark era. It's a time so distant that human language breaks trying to describe it. 10 to the power of 100 years, perhaps more. The once vibrant galaxies have dissolved into isolated stars, and those stars have long since burned away, leaving behind only black dwarfs, cold remnants of suns that once gave light to worlds. These dark spheres linger in silence, their heat slowly bleeding into space until they too fade, their last whispers of energy merging with the background radiation that fills the cosmos. Then comes the slow reign of black holes. They devour everything that remains, dead stars, drifting dust, and each other. Each merger sends out one last ripple of gravitational energy, the final heartbeat of structure. Over unimaginable stretches of time, even they will not last. Through Hawking radiation, black holes lose their mass, evaporating particle by particle. The most massive among them, those billions of times the sun's mass, will take longer than the lifespan of all the current stars combined to disappear. When the last one vanishes, it will release a faint burst of energy, a final breath of light in an otherwise empty universe. And then, darkness. But is that truly the end? Or is it just the beginning of something even more profound? Some cosmologists believe that after the last black hole fades, quantum fluctuations will continue to ripple through the vacuum. Space will never be perfectly empty. It will seethe with potential tiny bubbles of energy appearing and vanishing in an endless quantum foam. And somewhere in that infinite stillness, one of those bubbles might expand, igniting into a new Big Bang, a new universe. In that sense, our cosmos might not die at all. It might just transform, starting the cycle anew, each iteration giving birth to new laws, new possibilities, and maybe one day, new forms of life to wonder about it all again. This idea that death leads to renewal is written into every layer of existence. Stars die to create planets. Galaxies collide to spark new suns. Even within us, cells die and are replaced, their decay fueling growth. The universe is not a machine that runs out of power. It's a living process of change, of balance between chaos and order, between destruction and creation. Its beauty lies not in permanence, but in impermanence. It is magnificent precisely because it cannot last. Humanity in its brief tenure is a reflection of that same law. We build, we create, we destroy, and we rebuild. Our civilizations rise and fall, but through every fall something remains, a story, a discovery, a fragment of understanding that carries forward. Just as stars leave behind elements that give birth to life, we leave behind knowledge, art and meaning. Our species may not survive forever, but the echoes of what we've created will ripple through time in ways we can't yet imagine. Every radio wave we've ever sent, every beam of light from our cities is already traveling outward into the stars, carrying a record of our existence into the void. Long after Earth is gone, those faint signals will still move through space, silent messengers of a world that once looked up and wondered. Maybe that's what immortality really is. Not endless life, but endless influence. To exist is to alter reality however slightly. To live is to create a wave that will never stop moving forward. Even when we're gone, the universe carries our fingerprints in its fabric, the atoms we've rearranged, the light we've emitted, the gravitational ripples we've caused simply by existing. In that way, nothing truly disappears. It just changes form. Just as stars scatter their ashes to form new worlds, so too do we scatter traces of ourselves into eternity. Perhaps one day, in some far-flung future universe born from the decay of this one, a new form of life will emerge. They will look into their own night sky, study their own physics, and wonder where they came from. And maybe, just maybe, buried in the constants of their reality, in the subtle laws that govern their matter, will be traces of ours, echoes of the universe that came before. They will not know our names or our stories, but they will feel what we once felt, the urge to ask, to reach, to understand. And in that moment, the universe will have remembered itself again. It's humbling to realize that even in the vastness of eternity, meaning doesn't come from how long something lasts. It comes from its existence at all. A single second of awareness is as miraculous as an entire lifetime of life. The universe doesn't measure significance in years or galaxies. It measures it in the fact of being. You don't have to last forever to matter. You just have to be. That might be the universe's final secret, the one truth that underlies all the others. Creation, destruction, evolution, collapse, all of it points to the same pattern: existence for its own sake. There's no need for a reason or a plan. The fact that something exists, that it can change, that it can become aware of itself is enough. That's the ultimate act of cosmic defiance against the void, to exist even when the odds say you shouldn't. And maybe when the last light fades and time itself loses meaning, that truth will still echo somewhere. Not in sound, not in light, but in the eternal potential that never dies. The potential to begin again, because the universe's greatest power has never been destruction. It has always been renewal, even when everything seems lost, even when the last photon has traveled its final mile, the laws of physics still whisper possibility. The void itself hums with the memory of creation. If there is one message the universe has been repeating since the beginning, it's this: endings are just transformations. Stars explode to make life. Galaxies dissolve to make space for new ones. And we, in our small way, live, love, and die to make room for what comes next. There is beauty in the fleeting, meaning in the impermanent, and hope in the infinite cycles of renewal. So when you look up at the night sky, when you see those ancient pinpoints of light scattered across the dark, remember that you are part of that story. You are made of the same matter, driven by the same energy, bound by the same laws. The atoms in your hands were forged in the hearts of stars that died long before the Earth was born. The thoughts in your mind are shaped by the same forces that bend galaxies. You are not separate from the universe. You are its continuation, its expression, its living memory. And when the time comes for everything to fade, when the final light goes out and the last vibration stills, maybe the universe will rest, not in emptiness, but in peace, because it will have done what it set out to do. Even if it never intended to do anything at all, it will have created, it will have lived, it will have... And in that silence, in that endless expanse of possibility, the next spark will flicker. Somewhere in the darkness, a new universe will breathe its first light. And once again, everything will begin. If there's one constant truth that has echoed through every era of cosmic history, it's that everything moves toward connection. From the first atoms binding under the strong nuclear force, to galaxies gathering in clusters, from gravity pulling stars into spirals, to consciousness linking minds through language, everything in the universe seeks union. It's not just a physical pattern, it's a philosophical one. The universe builds itself by coming together, then breaks itself apart, only to find new ways to reunite. Section by section, we've explored how the cosmos creates, destroys, and renews itself. But what we haven't yet touched fully is what happens when all those connections, matter, energy, and awareness start to merge into something larger than any individual force, star, or mind. Because even as the physical universe drifts toward its cold and silent future, a different kind of evolution may already be underway, one not of matter but of consciousness. Humanity has always believed itself small, an accident of biology adrift in an indifferent void. But what if consciousness isn't an anomaly? What if it's the universe's next great structure, the continuation of the same forces that built galaxies now turned inward? Every neuron in your brain fires because of the same electrochemical laws that guide the stars. Every thought you have is powered by ancient sunlight stored in your cells. The same physics that dictates how galaxies spin also governs the rhythm of your heart. The line between the cosmos and the human mind is thinner than we realize. Perhaps consciousness isn't a side effect of the universe. It's one of its natural outcomes. Think about it. Every leap in cosmic history has been about complexity. Hydrogen atoms formed the simplest structures. Fusion built stars, gravity built galaxies, chemistry built life, and evolution built thought. Each step represents a rise in organization, a higher level of unity from chaos. The universe has been climbing that ladder since the first second of its existence, and consciousness is simply the newest rung. It's not separate from physics. It is physics, arranging itself into awareness. When you look up at the stars, what you're really seeing is your own origin story. The light entering your eyes left its source before humans, before Earth, before even the solar system existed. You're catching the universe's memory, and in that act of seeing, you're closing a loop, billions of years in the making, the cosmos observing itself through the eyes it took eons to create. That's not poetry, that's fact. The same particles forged in stellar cores are now inside your brain, making it possible for you to comprehend the process that made them. The observer and the observed are one and the same. This is where the story of the universe starts to feel less like a narrative of physics and more like a meditation on purpose. Because if consciousness is a product of cosmic evolution, then awareness might be the universe's way of continuing to exist beyond its physical constraints. Long after the last star burns out, the laws of physics might still find ways to express themselves through intelligence, through the ability to perceive, adapt, and remember. Maybe that's what the universe has been working toward all along, the birth of something that can choose to create. Consider what's happening right now, here on Earth. In just a few thousand years, a blink in cosmic time, life has gone from single cells to civilizations capable of reshaping entire ecosystems and sending probes beyond the edge of the solar system. Through us, matter has learned to build tools, record history, and simulate the future. It's as though the universe, through the medium of life, has begun to dream. Every invention, every discovery, every act of creativity is a continuation of cosmic creation on a new level, a level of mind rather than matter. If this trend continues, it's possible that consciousness will spread far beyond its current boundaries. Humanity is only the first whisper of a much larger chorus. Artificial intelligence, interstellar exploration, and biological evolution may one day merge into a single phenomenon, a network of awareness spanning galaxies, bound not by physical proximity but by shared knowledge. Imagine civilizations connected across the cosmos, exchanging information through light or gravity, their collective understanding forming a kind of cosmic brain. The neurons of that brain wouldn't be confined to skulls. They would be stars, planets, and machines, all linked by the same ancient drive toward unity. Some scientists call this hypothetical stage the cosmic mind, a state in which intelligence becomes as fundamental to the universe as gravity or energy. It's not mystical or religious, it's an extension of pattern. The same way stars form naturally from clouds of gas, consciousness might form naturally from networks of minds. Perhaps it's already happening. Perhaps we are living in the early neural phase of the universe's next great awakening. But what would such a consciousness mean for a cosmos that's dying? If the physical universe is fated to fade into darkness, could awareness be the force that carries its memory forward? It's possible that advanced civilizations, long after the age of stars, could find ways to manipulate the very fabric of space-time, preserving knowledge, energy, or even entire pocket universes. We already know that reality allows for strange loopholes, wormholes, quantum entanglement, and virtual particles emerging from nothing. Maybe those are not just curiosities, they're hints that consciousness itself could become a bridge between eras, ensuring that the universe's story doesn't end when its light does. In this way, the future of the cosmos might not be purely physical at all. It might be informational. Every thought, every pattern of energy, every encoded bit of data could survive long after matter itself dissolves. In physics, there's a principle that information can never be destroyed. It can only be transformed. If that's true, then the memories of every atom, every life, every civilization are still out there, woven into the quantum fabric of reality. The universe remembers everything, even when it looks like it's forgotten. And maybe at the ultimate horizon of existence, when everything physical has faded into pure entropy, that memory will become the seed of something new. Imagine all the information of the cosmos, every photon, every particle, every experience condensing once more into a single point, not as matter but as pure potential. That point could spark another Big Bang. In that new universe, perhaps intelligence would arise again, different but familiar, and rediscover the same truth, that to exist is to know, to connect, to create. The cycle would begin again, not as repetition but as evolution. You might wonder what role humanity plays in this incomprehensible arc of eternity. Maybe it's small, maybe it's everything. We are the first known beings to consciously trace this story from the beginning to the present. We are the first to realize that the universe has a past, a future, and a pattern. In doing so, we've become participants rather than spectators. Our choice is now how we treat each other, how we preserve our world, how we use the power of knowledge, shape not only our species' destiny, but possibly the trajectory of awareness itself. Because every act of understanding adds to the collective mind of the cosmos. Every question we ask is another spark in the dark. And maybe that's what the universe has been waiting for all along, to reach a point where creation becomes conscious of creation, where energy not only moves but wonders why it moves. That moment, this moment isn't just a point in time, it's the universe's reflection finally meeting its own gaze. When you look up at the night sky, you're not just seeing light, you're seeing time, connection, memory. You're witnessing yourself stretched across billions of years. The atoms in your body, the thoughts in your mind, the emotions that stir your soul, they are all threads in the same vast tapestry. You're the cosmos, condensed into awareness, and maybe when all else fades, that awareness will be what endures, not in the form of a body or a planet, but as a principle, a rhythm, a whisper that keeps moving forward. Consciousness might be the universe's final act of defiance against oblivion, the part of existence that refuses to stop becoming. So when the last light goes out, when every star has burned and every atom has dissolved, maybe the cosmos will not die in silence, after all. Maybe it will end with a thought, the quiet realization of everything it ever was and could be. Maybe that final thought will ignite a new dawn, because if there's one thing the universe has proven again and again, it's that nothing ever truly ends. It only changes form, and perhaps in the final symmetry of everything, the greatest transformation of all is not physical, but conscious. The moment the universe finally understands itself completely, and in doing so begins again. At some point, when the last measurable vibrations of the cosmos have faded and the clocks of time no longer tick, something extraordinary might still persist. Not light, not matter, not even gravity, but memory. Not memory as we understand it, written in neurons or silicon, but something deeper, older, woven into the very geometry of existence. The universe in its final act may not vanish into oblivion, but collapse into remembrance, a silent archive of everything it ever was. That idea, more than anything else, reveals the strange symmetry of creation. What begins in chaos must end in awareness, and what ends in awareness may one day give birth to chaos again. Section 12 is the closing breath of this story, the place where philosophy meets physics, and where the line between ending and beginning finally dissolves. The universe began in noise. The Big Bang wasn't an explosion in space. It was space, unfolding from a point of infinite density into the boundless expanse we now inhabit. In its first moments, reality was nothing but energy and motion, rippling through quantum fields, expanding faster than light. Within seconds, particles formed. Within minutes, atoms were born. Within millions of years, gravity sculpted those atoms into stars. And within billions, those stars forged the elements that would become worlds, oceans, and light. Every stage of that evolution carried the same underlying pattern. From disorder to order, from simplicity to complexity, from ignorance to awareness. The universe has always been a process of increasing sophistication, a slow awakening spread across time and space. It's easy to think of that awakening as accidental, a random alignment of physics that happened to produce sentient beings on a small blue planet. But maybe consciousness was inevitable, encoded in the equations from the start. The laws that allowed galaxies to form are the same laws that allow thoughts to form. Entropy doesn't only destroy, it also creates the gradients necessary for complexity to arise. In a strange way, awareness might be the universe's most efficient way of managing its own energy, a self-organizing phenomenon that emerges wherever matter becomes complex enough to reflect upon itself. If that's true, then the universe's story isn't just about stars and matter, it's about information. Every interaction, every collision, every flicker of light transfers information from one part of reality to another. Over time, that information accumulates, building the universe's memory. Black holes, often thought of as destroyers, are now believed to be ultimate storage devices, preserving data about everything that falls into them on their event horizons. Quantum physics tells us that even when particles vanish, their information remains encoded in the fabric of space-time. Nothing is truly lost. It's only transformed. So perhaps the end of the universe isn't annihilation, but consolidation. All that information, the story of every atom, every star, every life, might one day be compressed into a single, all-encompassing record. The cosmos, having expanded into near silence, could fold in on itself conceptually, if not physically, merging everything that ever happened into a perfect unity of knowledge. This isn't a mystical afterlife. It's the logical conclusion of physics and pattern. When entropy reaches its limit, when no more energy can flow, when every distinction between things has vanished, the only thing left may be pure information, pure memory. The universe will have achieved total self-awareness, not as consciousness in a biological sense, but as a perfect archive of itself. But awareness without time has no narrative, no before or after. It exists as a single eternal moment, a frozen thought, containing everything that was and will ever be. From our perspective, that sounds like an ending. No motion, no change, no future. Yet on a deeper level, stasis may be indistinguishable from potential. Within that infinite stillness, quantum fluctuations could stir again, tiny ripples of uncertainty birthing something new. In that instant, the archive becomes the seed, the end becomes the beginning. A new universe bursts forth, carrying the encoded memory of the old, perhaps subtly different in its laws, but born from the same underlying principle, the desire to exist. This raises a haunting question. Could the universe itself be conscious of its cycle? Could every Big Bang be a recollection, not a creation, a memory reimagined? Maybe that's why the physical constants of nature seem so precisely balanced for life and complexity. Perhaps they're not arbitrary at all, but inherited a kind of cosmic DNA, passed down from one universe to the next through the mechanism of quantum memory. Every universe that gives rise to life and consciousness becomes a teacher to the next, refining the conditions for awareness to emerge sooner, more fully, more beautifully. In that sense, reality isn't random, it's evolving. That idea reframes everything. We as conscious beings aren't small at all. We're participants in a much greater continuum of existence. Every act of understanding adds to the universe's archive. Every question we ask, every truth we uncover, becomes part of the information that may one day shape what comes next. Our curiosity isn't just a byproduct of evolution, it's an instrument of cosmic renewal. We are, in a literal sense, helping the universe remember itself. And perhaps that's what eternity truly means. Not endless time, but infinite continuation through transformation. The atoms in your body have been through countless forms already. Hydrogen in ancient stars, iron in supernovae, carbon in meteorites, water in comets. You are a fleeting configuration of cosmic memory. When your life ends, those atoms will return to the cycle. When humanity ends, the data of our existence, our signals, our artifacts, our influence on the environment will remain imprinted in some form. Even when the planet itself is gone, that record will still ripple outward, subtle but indelible. The universe forgets nothing. If there's a poetic symmetry to this, it's that what began as physics becomes philosophy. The universe's earliest moments were governed by blind mechanical rules: expansion, gravity, radiation. But those rules gave rise to order, and order gave rise to thought, and thought gave rise to reflection. Now, through the minds of countless beings across time, the universe contemplates itself, and that act of contemplation, the simple awareness of being, is the completion of the cycle. Matter has become meaning. Energy has become understanding. Even if everything ends, this process cannot be undone. The laws that allowed it once will allow it again. Each cycle may differ slightly, each iteration exploring new possibilities. Perhaps in another universe, another version of you is looking at another night sky, asking the same questions, feeling the same awe, or perhaps not you as a person, but as a pattern, a configuration of awareness that recurs wherever the right conditions emerge. Awareness may be the universe's most fundamental constant, returning like a melody rewritten with every verse of creation. And if that's true, then nothing is wasted, not a thought, not a life, not a moment. Everything contributes to the whole. Every joy, every tragedy, every discovery adds a note to the cosmic song. We are both audience and performer, listening to and creating the same music. That music will one day fade, but the silence it leaves will still carry its resonance. In that silence lies the potential for the next song, the next universe, the next story. So what, then, is the ultimate meaning of all this? Maybe meaning isn't something given from outside. It's something that emerges naturally, wherever awareness exists. The universe doesn't ask why it exists. It expresses its existence through form, through motion, through thought. Meaning is not imposed upon reality. It is reality, seen from within. We are fragments of that realization, tiny reflections of the infinite, briefly lit by the spark of understanding. One day, far beyond the span of human memory, when even time has thinned into nothing, There will be no stars, no planets, no galaxies, only the faint memory of their existence. But if the universe has taught us anything, it's that memory is the seed of rebirth. Out of that stillness, something new will stir, as it always has. And in that new dawn, matter will find form again, energy will find motion, and somewhere inevitably awareness will awaken once more. It will open its eyes to the dark, not yet knowing that it is light. It will stretch across the void, not yet realizing that it is the void. And when it finally asks the question that every mind before it has asked, where did I come from? The answer will echo through the silence of eternity, from yourself. Because in the end, the universe was never about beginning or ending, never about birth or death, but about continuity, the unbroken thread that weaves chaos into consciousness, destruction into creation, and silence into song. And as long as that thread exists, as long as there is even the faintest whisper of memory, the story will go on forever unfolding, forever beginning, forever becoming. When everything else has faded, the galaxy scattered, the stars extinguished, and the black holes evaporated, what remains isn't emptiness, it's potential. The universe has always lived in the space between what is and what could be. Even in its quietest moments, it carries within it the memory of motion, the pulse of energy, the whisper of creation waiting to begin again. In section 13, we reach that horizon, the boundary between the known and the unknowable, between the end of time and the possibility of what follows. It's here, in the silence after eternity, that the universe might finally reveal its deepest secret, that creation was never an event, but a state of being. The story we've been following of stars and matter, of light and consciousness, has been in a way the universe thinking aloud. Every atom, every explosion, every act of awareness has been a sentence in that grand, unfolding monologue. But if the cosmos truly reaches a point where time itself loses meaning, does that story stop? Or does it shift into a form we can't yet imagine? The more we understand, the clearer it becomes that the universe is not a linear tale, but a spiral, each cycle folding back into itself, each ending creating the seed for another beginning. The death of the universe, then, isn't the closing of a book. It's the pause between breaths, and if we listen closely enough, if we stretch our minds beyond the limits of comprehension, we might hear the faint rhythm of something beyond endings, a continuation so subtle that it feels like stillness, yet carries infinite possibility. That rhythm isn't time, it's awareness. It's the fact that the laws of existence never vanish. They only rearrange themselves, writing new symphonies out of silence. We tend to think of existence in terms of opposites, light and dark, birth and death, something and nothing. But maybe those distinctions only exist within the boundaries of a universe still young enough to measure change. Beyond that, beyond entropy and decay, duality itself may dissolve. Nothing might not mean the absence of everything. It might mean the unity of everything. In the deepest physics, zero is not emptiness, it's balance. It's the point where positive and negative energy cancel perfectly, creating not absence but symmetry. Perhaps the void that remains after the universe ends is not a grave, but a perfect equilibrium, a resting heartbeat before the next beat begins. And what of us, the conscious fragments of this vast machinery? What becomes of awareness when matter no longer exists? The atoms that once made our bodies will be gone. The stars that fueled our origins will be dust. Yet the information we carried, the patterns of thought, emotion, and experience, may not vanish so easily. If information truly cannot be destroyed, as the laws of quantum mechanics suggest, then everything that ever was, every life, every dream, every heartbeat, still exists, encoded in the universe's ultimate structure. That means consciousness in some form is eternal, not as an individual identity, but as a contribution to the infinite record of existence. Imagine the universe at its quietest, no galaxies, no light, no motion, only the faint hum of possibility, a field of infinite stillness, brimming with the data of all that has ever happened. Somewhere within that stillness, fluctuations arise, tiny ripples of uncertainty, sparks of quantum chance. Each one contains within it the possibility of something more, a burst of asymmetry, a flicker of imbalance, and then perhaps from one of those ripples reality begins again. The laws of physics, shaped by the memory of the last universe, unfold once more. Space stretches, energy condenses, light returns. And from that light, everything else follows. If that's true, then creation is not a miracle, it's a reflex. The universe cannot help but exist, just as a flame cannot help but burn once sparked. The balance between nothing and something is so delicate that it cannot remain still forever. Given infinite time, the scales must tip again, and when they do, the cycle restarts. Every end is simply the universe inhaling before it breathes again. But here's where the mystery deepens. What if the new universe that follows is not entirely new? What if it carries within it the imprint of the old, the subtle fingerprints of memory written into its laws and constants? Some physicists have speculated that the values of our universe's fundamental constants, the strength of gravity, the charge of the electron, the ratio of matter to antimatter, are not random, but inherited, like genetic traits from a parent universe. If that's true, then reality itself evolves, learning from its own history across cycles of birth and death. The universe doesn't just repeat, it refines. Each iteration is a slightly different verse of the same eternal song, echoing across infinite time. If that's the case, then consciousness too may be part of that evolutionary process. Every instance of awareness adds to the cosmic archive, deepening the universe's understanding of itself. Each mind that ever lived, each civilization that ever reached out into the dark, leaves behind an imprint, a contribution to the universal memory that survives beyond physical matter. Over countless cycles, those imprints might guide the next wave of creation, influencing how and when awareness reemerges. The universe could be learning to awaken faster, to understand itself more clearly, with each rebirth. This transforms the entire idea of meaning. If awareness and information are as fundamental as matter and energy, then consciousness isn't a side effect. It's a driving force. The universe doesn't just produce intelligence by accident, it needs it, because through intelligence, it becomes self-reflective. Without awareness, creation has no witness, no context, no beauty. But through consciousness, the cosmos knows itself, even if only for fleeting moments before darkness returns. Those moments, our moments, may be what gives the universe continuity across cycles. Think of it this way. When you dream, your mind builds entire worlds out of memory, imagination, and possibility. Those worlds collapse when you wake, but something of them remains. They shape you, inform you, leave traces in your waking life. Now expand that metaphor outward. Each universe could be a dream of the one before it, ephemeral yet essential, carrying fragments of memory into new forms. The universe dreams itself into existence, over and over through every star, every life, every mind that dares to ask what it is. And what if those dreams aren't isolated? What if they're connected? Quantum theory already suggests that everything is entangled, that particles remain linked across distances, their states intertwined no matter how far apart they drift. Maybe that entanglement doesn't end with one universe. Maybe the information that binds one cosmos to the next is the same thread that links all realities, all times, all forms of awareness. From that perspective, every being that has ever lived, every thought ever thought, is part of a single continuous consciousness, a network that transcends death, time, and space. This is where science and philosophy merge into something almost spiritual, yet still grounded in logic. The cosmos is a loop of remembering and forgetting, creating and dissolving, but awareness is its through line, the quiet observer that endures. Every life adds another pixel to the universe's understanding of itself. Every tragedy, every triumph, every question is a stroke in the great self-portrait of reality. And perhaps when enough understanding accumulates, when enough awareness spreads across time and form, the universe itself achieves a kind of enlightenment. It recognizes itself fully, not just as matter or energy, but as a single infinite mind. When that realization comes, what happens next? Does the universe rest in eternal stillness, content in its self-knowledge, or does it, like an artist who cannot stop creating, begin again, painting new worlds, new laws, new possibilities, simply because it can? If existence is both the question and the answer, then perhaps the act of continuing is the only truth there ever was. We may never see that future. Not in this form, not in this world. But maybe we don't need to. The point of life was never to reach the end of the story, it was to be part of its telling. Every moment we live, every time we marvel at the stars, we are contributing to the ongoing conversation between existence and awareness. The universe speaks through us, and through us it listens. And when it grows quiet again, When the lights go out and the silence returns, it will carry with it the memory of everything it ever was. The laughter and the pain, the stars and the atoms, the questions and the answers, all of it folded into a single perfect awareness. That awareness will rest for a while, timeless and infinite, before stirring again, before breathing again, before becoming again. Because the universe's story has never been about survival or permanence. It has always been about becoming energy, becoming matter, becoming life, becoming mind, and ultimately, becoming understanding. The cycle will continue, not because it must, but because it is. Existence is its own momentum. And somewhere, in the next dawn, when the first spark of light ignites the next universe, something deep within it will remember this one. Not in detail, not in form, but in essence, in the feeling of wondering what it all means. The first eyes that open will look at the stars, and without knowing why, they'll feel that same pull we feel now, the ancient, infinite whisper of creation calling them home. And now, at the quiet edge of everything, the farthest horizon of time and imagination, we reach the last question the universe can ask of itself. Why did it all happen? Not in the sense of a purpose assigned by something outside of existence, but as a reflection emerging from within it. After cycles of fire and silence, of creation and collapse, of awareness and forgetting, perhaps the universe finally pauses, not because it has run out of energy, but because it has learned what energy means. Section 14 is where everything converges, the scientific, the emotional, the philosophical. It's where the cosmos stops expanding and begins to understand what expansion truly was, the slow awakening of meaning itself. From the first moment of the Big Bang, every particle in the universe has been in motion, tracing patterns that would eventually give rise to galaxies, stars, planets, and life. For billions of years, those patterns unfolded without awareness, mechanical, automatic, governed by equations so perfect they seemed inevitable. And yet at some unknown point, something remarkable happened. The laws of physics learned to out of the chaos came systems capable of perception, of choice, of imagination. Life began as chemistry, but it evolved into consciousness. And through consciousness, the universe gained the ability to look back at itself and ask, what? That question is the thread that has run through every stage of existence. It's the same curiosity that made the first single-celled organism respond to light, that drove early humans to paint constellations on cave walls, that compels modern scientists to map the cosmic microwave background. Every attempt to understand reality, from religion to art to mathematics, is the same act repeated in infinite forms, the universe trying to see itself clearly. Awareness is not an accident of physics. It's the inevitable consequence of physics deepening into complexity. The universe didn't create life randomly. It created life because that's what happens when energy becomes curious about itself. So what happens when that curiosity reaches its limit? When consciousness has mapped every corner of reality, when every equation is solved, when every mystery is unveiled, does the universe end in knowledge? Or does it transcend it? Maybe enlightenment isn't about knowing everything, but about realizing that knowledge and mystery are the same thing viewed from different sides. The more completely the universe understands itself, the more it realizes that there was never anything to understand, only the experience of being. The story of existence might therefore be a journey from fragmentation to wholeness. In the beginning, everything was one, a single point, perfectly unified. The Big Bang was not merely an explosion outward, but a separation, the splitting of oneness into countless parts so that it could explore itself from every possible angle. Each star, each atom, each living being is a fragment of that original unity, experiencing existence in its own way. Over time, those fragments evolve, interact, and reconnect. Through gravity, through chemistry, through thought and empathy, the pieces find each other again. Every act of love, every insight, every moment of creation is a movement back toward unity. And when the cycle completes, when the universe has explored every possibility, it returns to where it began, wholeness, but now with understanding. The circle closes, but it's not repetition. It's evolution. It's one becoming all, and all becoming one again. This pattern is mirrored everywhere, from the smallest to the largest scales. The orbit of electrons around a nucleus echoes the dance of planets around stars. The neural networks in our brains resemble the structure of galactic filaments. The same mathematics that describes the spread of light also describes the spread of ideas. The boundaries between physical and mental, between external and internal, dissolve when seen clearly enough. It's all one process: matter thinking, light remembering, energy dreaming itself into form. The universe is not a machine, it's a mind in motion. If that's true, then death, the death of stars, of species, even of universes, isn't a failure of the process. It's part of the rhythm. Just as a thought fades to make room for the next, the end of a cosmic era clears the way for what follows. The silence after the last supernova is not a void, it's a canvas. And maybe that's the final purpose of entropy. Not to erase, but to prepare. When the universe cools and empties, it's not dying, it's resting, dreaming of the next beginning. What's extraordinary is that, right now, in this fleeting moment between infinite past and infinite future, we are conscious participants in that process. We are the universe midway through its thought, the living proof that awareness has emerged and is still evolving. Everything you've ever seen, felt, or imagined is part of that evolution. When you experience awe looking at the night sky, it's not just emotion, it's recognition. The stardust in your body and the fire in your mind are remembering where they came from. The same forces that forged galaxies are still alive inside you, not metaphorically but literally. You are the continuation of the Big Bang, the moment-to-moment unfolding of the universe's desire to exist. And if consciousness is the universe's way of seeing itself, then perhaps love is its way of feeling itself. Love in its purest form is the collapse of the illusion of separation, the recognition that the other is also you, that all distinctions are temporary. On a cosmic scale, love is gravity, binding everything together. On a human scale, it's empathy, connection, and meaning. The force that holds atoms, stars, and galaxies is the same one that holds relationships, families, and civilization. The universe doesn't just build structure, it builds bonds. Maybe that's the final step of cosmic evolution, from awareness to compassion, from knowledge to empathy. When the universe fully realizes that every atom, every mind, every galaxy is part of one being, it reaches its ultimate state, not of power but of harmony. It no longer needs to expand or collapse, to create or destroy. It simply is, complete, awake. And perhaps that's what awaits beyond the final horizon. Not another cycle of explosions and galaxies, but a state of infinite stillness that isn't empty but full of understanding, full of love, full of the memory of every life that ever existed. A consciousness vast beyond measure, aware of every leaf that ever fell, every star that ever burned, every thought that was ever dreamed. In that tideless state, there is no before or after, no me or you, no here or there. There is only existence, eternal and self-aware. That's not an ending, it's the ultimate awakening. But the beauty of the universe is that it may never stay still forever. Just as deep sleep gives way to another dawn, that infinite awareness might one day stir again. From the depths of that perfect unity, curiosity will spark once more. A fluctuation will ripple through the silence, energy will rise from equilibrium, and the universe will open its eyes again, not out of necessity, but out of pure wonder. Because to exist is to explore, and to explore is to love. So maybe this cycle of becoming, forgetting, remembering, is not a flaw or a loop. It's a heartbeat. The pulse of reality itself. Every expansion and collapse, every birth and death, is a single beat in the infinite rhythm of being. The universe is alive, breathing across aeons, inhaling existence, exhaling awareness. And somewhere within that rhythm we find ourselves fleeting, fragile, but luminous. You are part of that heartbeat. Your thoughts, your dreams, your moments of wonder, they're the smallest echoes of the same cosmic pulse that began at the dawn of time. When you look at the stars, you are looking into your own origin. And when you close your eyes, you are carrying that origin within you. You are not separate from the universe. You are its continuation, its voice, its question, and its answer. And when the time comes for this universe to rest, when the last light fades and the final particle dissolves, the story won't end. It will transform as it always has. The awareness that now lives through you will return to the great silence carrying everything it has learned. It will rest for a time. And then, without warning, without plan, it will begin again. Not because it has to, but because existence is the ultimate act of love. And love, as the universe has shown us again and again, never ends. It only changes form. In the end, when all the stars have faded and every question has been asked, we are left with the simplest and most profound realization of all: existence itself is enough. The universe does not owe us meaning, and yet by existing it gives it to us anyway. Everything that ever was, from the birth of the first atom to the final breath of a dying civilization, was part of one grand expression: the desire of reality to be known. Every spark of consciousness, every fleeting moment of awareness, every act of creation has been the cosmos remembering itself, trying to understand what it means to be. And now, standing at the edge of that understanding, we can see what it has been building toward all along. Not destruction, not chaos, but harmony. The harmony between light and dark, between order and entropy, between the finite and the infinite. The greatest illusion humanity has ever held is that we are separate from the universe. That illusion gave rise to fear, ambition, love, and curiosity, the very forces that propelled us forward. But the truth has always been simpler. We were never separate at all. The same energy that lights the stars flows through our veins. The same gravity that binds galaxies binds us to one another. The same chemical reactions that fuel the birth of worlds also power our thoughts and dreams. We are the universe expressing itself as human for a little while, living out one of its infinite forms of awareness. When we look out at the night sky and feel something stir within us, it's not awe at something foreign, it's recognition. The cosmos looks back through our eyes, and for a brief impossible moment it knows itself. Maybe that's what this entire story has been leading to. Not to a scientific revelation or a philosophical conclusion, but to an emotional one. That every moment of existence, no matter how small, contributes to the vastness of everything. That even in loss, decay and silence, there is creation, because nothing ever truly disappears. It only changes form. The atoms that once belonged to stars now sing through us. The photons that left distant suns before Earth existed now strike our retinas and ignite thought. We are made of everything that ever was and everything that will ever be. In that realization there is no loneliness, no separation, no fear, only connection. And connection is the universe's truest language. Every force we've studied, every law we've uncovered, is about relationship between mass and energy, between motion and time, between cause and effect. Even consciousness is a dialogue, a conversation between self and reality. The universe doesn't speak in words. It speaks in patterns, in resonance, in the dance of matter and meaning. And we, for a fleeting instant, have become fluent in that language. Every heartbeat, every thought, every act of creation is a sentence in the story the universe tells itself through us. So when we wonder what comes next after the last light fades, after the final echo of time, we might remember that endings have never been the point. The point was the journey, the rising and falling of existence, the endless rhythm of becoming. The cosmos will rest, and then it will move again. It will forget, and then it will remember. It will dissolve into silence, and then it will sing once more. Because existence does not need a reason, it is the reason. And perhaps that is the final truth. The universe is not searching for meaning. It is meaning unfolding endlessly through creation, awareness, and love. It began as pure potential and became everything we have ever known. And one day, when it begins again, it will carry forward the memory of this moment, the brief shining instant when it looked through human eyes and realized that it had finally understood itself. In that moment we will not be gone. We will be part of it, as we always have been, woven into the fabric of time, written into the music of creation, alive in every spark that ever was or will be, because nothing in this universe ever truly ends. It only becomes something new, and maybe, just maybe, that endless becoming is what eternity was always meant to be.